Hello everybody and welcome to this webinar about synthetic test data versus data masking. My name is Maarten Ulbach and I will be your host and presenter for today. Unfortunately, when we started this webinar, we started to notice that the chat box or the Q&A box is not available for this session. But if you have any questions, we will try to give you an email address. So if there are any questions by the end of this webinar, you can post them via the email and you can ask us anything you would like. So it's a little bit of the difficulty, but never mind. We have a wonderful presentation today and I hope you enjoy it. So let's start with this webinar. Before we truly start, let me quickly introduce myself once more, a little bit more in detail. But my name is Maarten Ulbach. I'm managing partner of DATPROF. And during my time at DATPROF, I roughly have about 10 years of experience in the test data management area, helping customers out with all sorts of challenges they have with test data. But I also presented on several conferences in the past, for example, Test Expo or Eurostar. And my primary subjects and topics I would like to talk about are solving the test data bottleneck or test data architecture. And one of the subjects is always and will always be something about data protection, data regulation, because that's also part of this solving the test data bottleneck. With that quick introduction of myself, let's start with the real content for today. Data masking versus synthetic test data generation. And while I was preparing for this webinar today, or over the last couple of weeks, I was starting to think, why do we discuss this topic right now? Why haven't we discussed this topic a couple of years ago? What's the reason why we truly discuss data masking versus synthetic test data nowadays? And I came to the conclusion that probably one of the things that truly matter is that we all try to get compliant to data protection regulations, because that's the major reason why we even think about data masking or synthetic test data generation. But these data protection regulations were already present way back in the past. We have these data protection regulations for quite some time already. The only major difference maybe will be that we updated the data protection regulations over the last couple of months. So the last 24 months, quite some data protection regulations have been altered or changed or updated. And in our experience, but maybe there are also different data protection regulations, but we truly see that one of the major impacts that were generated is the GDPR in Europe. And that was one of the major things that caused maybe some others to change and updated their privacy regulations as well. And when I start searching on the World Wide Web and try to figure out what kind of data protection regulations have been altered over the last 24 months, I came to the conclusion that there were quite a number of data protection regulations which have been altered in the last 24 months. Not every single one that is in this slide deck is altered or changed or updated in the last 24 months. But most of them are. For example, in South Africa, you have a new one, but also in Brazil or in Canada or Japan have been updated. But what's not on this slide deck, for example, is also the updated versions that are coming into play from New Zealand, but also from Australia. So there are quite some updates that have come to the market over the last 24 months. But still, I wonder what's the real reason. And in the end, the real proper reason why we discuss more intensively and debate data masking versus synthetic test data generation is the fact that there's a higher business risk in the end. What we see is that due to the penalties which there is an increase and there's a higher business risk involved in not getting compliant to these regulations. And therefore, in most cases, people really are interested in what shall we do? Shall we make a decision to move towards data masking, or shall we make a decision towards synthetic test data generation? So a decision should be made in the near future, or you already have chosen one. But this is primarily the reason why currently there is much of interest in data masking or synthetic test data generation, in my opinion. And with that being said, I will try to help everybody in this webinar a little bit out by explaining how maybe you can decide which technique you should use in which scenario or which situation. And to do so, I firstly try to make sure that we are talking about the same things. So before we continue any further with this webinar or my presentation, I thought it would be wise to have at least the same definition about the different techniques that we tend to use. So I create a definition about, or I created, there's a definition on Google that I found about data masking. And data masking is in the end is the process of hiding original data with modified content. The real issue is, of course, is that there's already data available. So there is existing data, which can be in a database, for example, but for this presentation or for this webinar, I don't really care if it's in a database or in a different kind of source, flat files, whatever it may be. But what the end result is that you have already existing data and you will try to modify it. Techniques that can be applied or where you can think about are techniques like a shuffle, redaction, blank, scramble, all that sorts of rules, masking rules that can be applied, which helps you to modify existing content and therefore trying to hide it to not show the real content in itself. Synthetic test data generation, on the other hand, is a little bit differently. It's test data that you created based upon an algorithm, or you've used a seedless, for example. There's a bit of a difference between both. Algorithm means, in our opinion, or in my opinion, that you all will be generated it from scratch. It didn't existed before. Yeah, it doesn't have anything else. So you can think about new IBAN account numbers, or you can think about social security numbers. All that types of information can be easily synthetically generated for that purpose. Another way to get synthetic test data generation, for example, is the use of seed list. And what I mean with seed list is that, for example, you will have a list of most commonly used first or last names, and you will use this list to substitute data inside a table or a data source, for example. So you have the most commonly used first or last names, and you will substitute this information with the information that's in your source. So these are the two main differences. And now I want to help everybody out during this webinar about how you can make a decision which technique you should be using. And it's always interesting, in my opinion, to start simple. Because there's always an opportunity to introduce complexity later on. But if the basis is simple, it's always a foundation to start your process of your decision. So I try to make it as simple as possible from the start. So I started with a single system. You have only one system that you want to be getting compliant with privacy regulations or data protection regulations. The first question that came to my mind that we also experienced over the last couple of years is, what you can think about is it a new system, a new application, or is it already an existing application? And if it's a new system, for example, you can think about, is there already production data available? Maybe there is a data migration already in place, or maybe not. If it's not the case that there's any production data available, then probably there's only one real solution, one real opportunity that can help you out, and that's generate your test data synthetically. You don't have any other data, so you are obliged, the only way out is synthetically generate test data. On the other hand, you might have an existing system, which is the most common example probably. In an existing system, it really becomes dependent on the complexity of your system if you should choose synthetic test data over data masking, or maybe the other way around. In our 10 years of experience we've been in this area, or at least my 10 years of experience in this area, one of the major things, one of the major interests that we have when we start masking such a system, an existing system, is we are interested in the number of tables that is inside a data source. I will talk about database. There's some differences in sources, or for example, flat files. But in a database, we are primarily interested in the number of tables that are present in a database. And if there are If the fewer the tables, the more likely you can probably get somewhere in the area of synthetic test data generation. If there are more and more tables available in the database, you probably will more quickly become more reliant on data masking functionality. Because in our experience, probably the most commonly used corporate systems already, especially proprietary software, we typically see that there are quickly more than 1,000 tables that are influenced in the system, that are in the database available. And if you want to synthetically generate 1,000 tables consistently, that's already a painstaking work to do, because you can imagine, especially if those thousands of tables have multiple columns, that you have to generate quite a number of synthetic test data generators to make sure that your database is properly filled. And then I don't even talk about the consistency that that's also highly important in your database. So especially in the more complex environments, and then 1,000 tables might not even be so complex. We sometimes encounter databases with over 1,000, maybe sometimes 2,000, 5,000, tens of thousands of tables are sometimes present in corporate environments. And that's also interesting, if it's a smaller system, in most cases we tend to see it's roughly a self-built environment. So we self-develop their own system, and then in most cases it's not so complicated, there are less tables available. But especially in these areas, I think that data masking becomes more and more important if there are quite a number of tables available in a database. Another question you could ask yourself to try to get a decision is something you can think about is test data anomalies, as we tend to call it, or data quality. I think the best way to explain this challenge and why it influences the decision that you will try to make is with a small example. In the past, we've met a customer and we started implementing our software and we masked the database, but quickly there was a issue found, and they said to us, we found that the phone number has 9 digits, and our business application tells us, and it's making sure with a business rule, that there can only be 10 digits in a phone number. This cannot be possible. Your software solution, your data masking solution, has manipulated the data, and therefore now it's possible that we have a 9-digit phone number in our database. In the end, it wasn't the software, it was the garbage or the data quality issue that was already in place in the production environment. So we didn't change it, we didn't manipulate it, it was already in the system itself. And this small example tells us, and that's something you also have to think about, is that there are data quality issues inside a database, which can be really interesting, especially from a software quality perspective. Because in the end, I think most of you are not in the business of test data management. Most of us are in the business of trying to get software to the market or to production with the best possible level of quality. And therefore, having test data available that's really representative for production is highly interesting and highly valuable. And I truly doubt that it is possible to generate such test data cases with synthetic test data generation. And therefore, it might be really interesting to use data masking functionality over synthetic test data generation to make sure that all these different test data anomalies, these data quality issues, are still present in your test environments, in your test databases, in your development databases. So therefore, I truly think that sometimes you can choose data masking over synthetic test data generation to make sure that you have a representative set of test data to truly make sure that if you go to production, you will go to production with the highest level of quality. There are some other questions that you can also ask yourself. And that's also what I try to ask myself, especially in the decision model. And that's, what kind of test are we trying to execute? Because of course there are a number of tests that you will try to execute. And maybe based upon the test that you will try to execute, you have different requirements on the test data set. For example, for a unit test, I think that there's a lower degree of requirement for your test data than if it's in a regression or an integration test. So I can imagine that for a simple unit test, you might think that a synthetically generated test data might be useful. And I think so as well. Maybe it's useful enough to get a proper test, especially if it's a test for new features or new products. It's probably easier to synthetically generate test data than use data masking, because we don't even have these test data cases available in production because we introduced a new feature or new products, for example. But for a more, well, functional test or a regressional test, and in my opinion, a regressional test is a test in which we try to make sure that the existing system still is functional, but new developed features, new parts of the system should also be tested. So we're making sure that everything is still workable. And in this particular case, you can really think what should be more valuable. And I think in the end, in these circumstances, especially for regressional testing, it might be very valuable to have both techniques. I think in those circumstances, maybe it's worthwhile to have data masking functionality in place to make sure you're able to execute tests properly against the existing system, and that new functionality can be tested with synthetically generated test data. But then you should place them on top of each other. And the last part, of course, and that's also a test that we sometimes execute, is the test of volume testing. And especially for volume testing, there might be also the need for more synthetically generated test data, because then you can place different kinds of sets on top of each other, making sure that you have the right volume. If I'm telling it you right now, it seems easy, but in the end, that might be a little bit more complicated to do such thing, especially due to maybe primary key violations. So you really need to think properly about such a synthetically generated test data before you truly execute such synthetically generated test data sets. And with that being said, we all can see that already in a single system, it can become rather complex rather quickly. Even in a single system, data masking or synthetic data, the decision can be rather complex. But I think you should run through all the different scenarios to make sure which technique can prevail over the other, or maybe you can choose both. And when I started, I said I can always introduce complexity later. Well, of course, in the real world, the real world is a little bit more complex than a single system. And even this wonderful slide is probably a simplistic version of reality in your particular case. Probably your reality is even way more complex than this wonderful slide deck. But what I wanted to show is that at least in reality, it's getting rather complex rather quickly once more. And if you start thinking about which decision should I make between synthetic test data generation or data masking, I think that especially when you take a look at the complexity for synthetically generated test data in a single system, that can be rather complex from the start. So therefore, I think it's very interesting to start thinking about data masking technology in a multi-system environment, because especially in these multi-system environments, you probably have it workable in your production environment. And if you make a copy of your production environment and put it in your test environment, then at least you have the highest amount of certainty that it will also work properly in test environments. At least that's what we at least should be assuming, I guess. And probably also in production there are challenges, and there will also be challenges in test environments, but at least it's something that should be working in your test environment because it's also working in production. And then you can mask it. And there's another added complexity because you also need consistency over multiple systems, of course. But that can in the end also be done with data masking technologies. And with synthetic test data generation, it's getting rather complex because it's not already present. So you have to think about, you have to know all sorts of information about the application, functional, technical. So it's really a challenge and a painstaking work probably to do it with synthetic test data generation. So in most cases, when you think about multi-system environment, end-to-end compliancy, we strongly advise you to start using data masking at first and maybe generate synthetic test data on top of it to make test cases more aligned, maybe even perfectly aligned on your test cases. So to sum things up, to make a small bit of conclusion for the first part of this presentation. There are some benefits of both techniques. I think data masking, for example, is really recognizable. It's rather interesting also to use data masking technology for historical data, especially if you have a system which is already in use for several times. You probably have data that's really long present in your database, and synthetically generate these kinds of data. It can become rather complex, especially if there also maybe a migration has been taking place in the past. So I think in most cases, these are a little bit the benefits of using data masking. You have also the test data anomalies. It's mostly really representative for testing and software testing, of course. And test data generation, there are also some benefits because you can perfectly align your test cases with synthetic test data generation. You can even choose the number of data that's available. There are no dependencies. For example, you can do it straight from the start. There's no dependency on using other roles inside your organization, like DBA people that also are used, especially in a more data masking environment. So there are some benefits of both techniques. So in the end, I think if you want to compare and want to make a decision, this is something you should think about. In the end, as I mentioned in the sheet before, I probably think that the best foundation to start thinking about getting compliant is also using copies of production and start thinking about masking these and placing synthetic test data generation on top of it to align them with test. But then there's one major question that we should answer ourselves, and that's how do we then become compliant? Because that's a really interesting one. Because if you take a look at synthetic test data generation, one major benefit, of course, of synthetic test data generation is that you generated it. It's 100% absolutely fictive. It doesn't exist. It didn't exist. You're not trying to hide or modify content. No, it's non-existing data that you generate. And therefore, you're 100% compliant. But if you want to use production data, for example, well, then you really should ask yourself the question, how do we then get compliant? I will try to explain a little bit with the last couple of slides for this presentation. I asked myself the question when I came with the preparation of this webinar, how do we get compliant? I sometimes see different kinds of information when we talk about individuals or in persons or natural persons. And most typically I see words like PII data or personal data. And I was just wondering, is there any difference? So I started Googling once more and I quickly find out that PII data stands for personal identified information. And personal data is, well, I will show it later on. But the thing is that PII data is primarily originated from the United States. So in the United States, somebody figured or made a definition about PII data. And the interesting part is if you read this text more thoroughly, it's talking about linked or linkable information. It's also talking about the more privacy sensitive information as well. And if you compare this definition to the definition which is used in the GDPR, it roughly seems the same. But instead of with the PII data, they're talking about an individual, for example. In the personal data, they talk about a natural person. In the GDPR, they are talking about identifiable or identified indirectly related to an individual person or a natural person, I should say. In the PII data, it's more talking about linkable and unlinkable. So there are some small differences. But if you want to get compliant, if you want to still use sorts of copy of production databases, mask it to get a real representative set of test data for your software testing, for example, you should get compliant. And if we start such process, we typically at first try to look at two major components, two major parameters inside a database, how you can identify a person. And we typically divide this in two different groups. The first group is the identifiable group, we tend to name it. It's like the name, date of birth, all information that is rather quickly directly related to a single person. So in this particular, and if you ask, for example, to a service desk, they're asking, what's your date of birth and your street number, and then typically they quickly find an individual person. More characteristic information is a little bit different, but if you ask me, this is probably way more privacy sensitive information than the identifiable data content that's available in a database. Because if you ask me a bank balance or a debt of the mortgages or the kinds of medicine I'm using, these are really more privacy sensitive. It's more privacy sensitive information than if we talk about identifiable information. So roughly we start thinking about what's the difference. And now it's getting really interesting, because if we are able to unlink these two, so if we are able to unlink the identifiable part with the characteristical part, then we are getting compliant data. We can make sure that we get anonymized data, because based upon the identifiable information, we're not able to see the characteristics. That's the black and white story. I do understand that there's, of course, a gray area, and we should also think about the gray areas as well. But typically, when we start using or implementing data masking software to get you compliant or synthetically generate data, we typically like to look first at the names, date of birth, all that sorts of information. And for example, you can think, we can generate new first names based upon a seed list. We will giving everybody a new date of birth. In an insurance world, that might be a little bit more challenging, but maybe we can replace the date of birth with the first day of the same month, for example. But we can generate new bank account numbers, new addresses can be shuffled. So there are all sorts of masking or synthetic test data rules that can be applied to make sure that this data gets rather or completely masked or anonymized, so it will become compliant. In the end, that's not everything, because of course, the longest first name might be really directly related. So if you start shuffling this kinds of information, you should think about how you mask the different things. So in most cases, we also start with a bit of data discovery to make sure that we are aware of all the different information that's inside the database. What we try not to do, but that's not always possible, that's also true, is we typically don't like to touch base the characteristics. If it needs to be done, we will do it, and this is perfectly doable. But what you can understand, of course, is if we alter a bank balance, it's not only the bank balance which you should alter, because you want a consistent test database. Therefore, we should also change all the incoming and outgoing payments of the same bank balance to make sure that the bank balance is correct with all of the different transactions that have been placed by a customer, for example. So therefore, you will see that a single manipulation of a bank balance can be quite impactful. And that's also the reason why we tend to stay away from these characteristics. But if it needs to be done, it needs to be done, especially if you want to become compliant. One wonderful example that's also on this slide deck is, for example, salary. Maybe salary is a little bit more easy, but you can think, of course, that a higher salary can, of course, be already related to a single person. Especially if it's a high salary, then probably you're aware of the fact who will be the beneficial people of this salary. So therefore, there are also some sorts of tricks and data masking rules that we can apply to maybe lower the highest number of salary with 20%, and the lowest part of the salary we can increase with, for example, 20%. So in the end, it would become more in the average part. So there are quite a number of techniques that you can do, but with the end result that you will have a compliant test database. So there are quite a number of things that you can do to make sure that you will get compliant. And in the end, if I can do a small conclusion for now, I think in the end, what we really think that you should be doing, it's not like you should choose data masking over synthetic test data generation, or you should choose synthetic test data generation over data masking. In the end, we truly think that you should use both techniques. In the end, it's truly the possibility to use data masking and synthetic test data generation. And in our opinion, especially in a more corporate environments, start using data masking as a foundation and build perfectly nice synthetically generated test data on top of it, so you can even get it more perfectly aligned on your test cases, or you're able to execute future-proof features or system dependencies that you will need to execute your tests. What we try to develop as well, and that's one of my last slides for today, is we tried to develop this wonderful decision model. It's a first concept. I don't know if we are truly complete, it's fully complete yet, but I think it's a wonderful beginning at least. But with this decision model, I'm hoping that we can help you out in the decision, or at least a discussion about a decision, which technique you should use. Should you use the one over the other, for example? And it roughly has the same look and feel as I did during my presentation. So it's discussing and starting with if you have a single system, if it's no, is there production data available? Is it already appropriate for test? If it's not appropriate, maybe you should consider using synthetic test data generation. And so you can, well, answer all the single questions, and hopefully you will get an answer that's quite helpful. If you have any feedback on our decision model, please feel free to also contact us, because we can change it. And I think in the end, it's not something we want to have, but in the end, we want to try to help you out in the best possible decision. So this will also be shared with everybody that has joined this webinar. But if you have some feedback, please feel free to contact us, then we can change it, or at least we can have a discussion on the different answers that you can have in this decision model. And with that being said, I came to a conclusion of my webinar and my presentation. I hope you all enjoyed my presentation. I have prepared this last slide deck, but unfortunately it wasn't possible to post your questions in the chat box or in the Q&A box, because we made some we made a small error in the settings of this webinar. But if you have any questions, please feel free to contact us, because that's of course possible. You can contact me directly at maarten@datprof.com. So there we will try to answer all the different questions that you might have. Last thing I would like to mention is this webinar is recorded. So we recorded it for everybody, and we also will share these recordings by the end of this webinar, and we will try to send it to you over the next, well, probably maybe tomorrow, or otherwise the day after tomorrow, but hopefully as quickly as possible. So if you joined later, or you have to leave early, then you have the opportunity to see the full recordings of this webinar later on a chosen moment. And with that being said, I would like to thank you all for joining. I hope you enjoyed this webinar. I hope it helped you in making a decision about synthetic test data or data masking. And I wish you all a wonderful day. And I would like to thank you, and hopefully see you at another webinar of DATPROF. Thank you so much.